Okay, before we talk about subtraction and negative number, etc., we need to introduce a kind of boring but very important concept. Well, when I say it's boring, because people use lots of things to try to explain that, and I suggest you guys watch this beautiful song in the cartoon, "The Sword in the Stone." Merlin talking to King Arthur, the beautiful song, up and down. So the boring definition is the following. Here's the definition. So we defined two numbers, A and B, okay, we called opposite to each other. If A plus B equal to B plus A, I should put also equal to B plus A. If two numbers satisfy this property, it will be called the opposite to each other. For given number A, traditionally, we use minus A as its opposite number. And then you can see that if I put a minus A, this will be opposite of opposite A, of course it will be A. That's the way we write that down. Well, actually, we suggest using A hat instead of A. You will see the reason later on. Okay. Typically, we say the following thing, that is, A plus its opposite minus A equal to minus A plus A equal to 0. Or in our notation, we're using A plus A hat. That is same as A hat plus A equal to 0. Typical example is 1 and the negative 1. Even you have some kind of number you don't understand, for example, square root of 7. It's opposite, just put a minus sign in front of that. You can see that I read as a -1 or -1. Those are the terminology we borrowed from arithmetic, actually. And of course, you can just say -1, just the opposite one is also fine. Okay. So generally speaking, once we have this kind of opposite number, you can see that we introduce negative number, like -1. Essentially, -1 is just the opposite of 1. Okay, so therefore, after we introduce natural number 1, 2, 3, 4, and then their opposite will become like -1, -2, -3. The only special case is natural number is 0. Its opposite is itself. Okay, so that is the only difference. The opposite and the original number are the same. After we finish this introduction, we introduce the usual subtraction. So the subtraction will be defined as, so this is our definition. So whenever you do A minus B, it's just defined as A plus B's opposite. You can also using our new notation, say A plus B's opposite, okay? B hat. For example, if we do this 8 minus 3, instead of using your finger, and you do this rigorously, you can do the following things. That is 8 minus 3, which is same as 8 plus 3's opposite, okay? And of course, you can decompose 8 as 5 plus 3 and plus -3, right? So this actually you're using the associative rule. And then we can using another associative rule. We put this 3 and the -3 together, associative rule, and then we know by definition 3 plus -3 is 0. So you got a 5 plus 0, that is 5. Okay. You can also do a small number minus big number, like 3 minus 8. How you do that? Well, this is one way. We can do that because 3 actually is opposite of 5, that is -5 plus 8. So this is 3 here, okay? And then using associative rule, you can put this 8 associated with -8. So you can put like -3 plus 8 plus -8. This again, opposite number, 8 together equal to 0. Therefore, you got -5 plus 0, which will give you -5. A little bit complicated, but it works, okay? But I'll tell you an easy way later on. Here, I really suggest you guys using so-called the A hat instead of A for decimal number system, because later on, I will show you that if using decimal number system, you can denote like a 31 hat, which actually in decimal number just a 310 minus 1. Okay, in decimal number system, that's just a 310 coefficient, just minus, or can say plus, and -1 times 1. So you put the coefficient in front, you got the 3 1 head. Okay. So another number you can try, that is if I write down like a 4 2 head and a 1, this actually means that the 400 minus the coefficient now for 10th place is -2 minus 10 plus 1. That's the traditional number 381. Okay, I will give you an example to show you the advantage using this head notation, which actually is copyrighted by us. So if you use head here, we can do the following thing. For example, we do a small number minus big number, right? You can do the following things. That is, 3 plus 8 opposite, and again 3 actually is 8 plus 5 opposite. That is 8 minus 5, and plus 8 head. Okay, and then you use the associative rule. You can put 5 head out and put this 8 plus 8 head together. Again, this will be 0 because 8 is opposite of 8 head. Therefore, you got 5 head, which is -5. Okay, so I already explained that you can use head. This 31 head actually is 29. The 4 2 head 1 actually 381. Okay. There's another way to understand the above calculation for small number minus big number. Okay, here's we have to introduce the following fact, which is quite important also. The fact is, whenever you look at so-called opposite number a, actually this minus a, whatever this a is, could be a negative number, could be a positive number. Essentially, it's just a -1 number multiply a. This is quite important, okay? Because once you look at the say, so you can, of course, you can talk about by a community rule. You can talk about the same as a multiplied -1. So you can say, or negative a actually is a copy of -1. But obviously, when you talk about the -1 times -1, it does not make sense to say -1 copy of 1, because from now on, the multiplication is no longer the replacement of addition. Okay, it has a more advanced meaning for the multiplication actually. The reason negative a actually equal to -1 times a is the following, because we can check -1 times a plus a using so-called distributive rule. You just have like -1, you bring this one out, plus 1, bring a out actually. Therefore, you get -1 plus 1, which is 0. So that gives you 0. So this formula just said that it's essentially -1 times a is the opposite of a, which of course is the same as minus a, use our definition. Okay, and using this new notation, you can quickly see that whenever I'm using a small number minus big number, I can consider its opposite. So like this one, 3 minus 8, you can see this actually is opposite of, so 3 is opposite is -3, minus 8 opposite actually is 8, right? So therefore, that equal to -1 times -3 plus 8 equals to -5. It is also important to tell students to avoid the next mistake, because always we said it's not a careless mistake, but rather you have to understand. Typical example is when we tell students how to remove the parentheses. Okay, people will forget to change the sign for the second number. Case example. If you look at this -1 parentheses a minus b, okay, essentially it is -1 multiply a minus b. Now since it's multiplication, we have so-called distributive rule. So -1 multiply a, you got the first term, and -1 multiply -b, you got the second term. -1 times b gives the second term. Then you got the first term with -a, and the -1 times -b according to effect is b. So therefore, I can minus a plus b. So therefore, you have to change the sign for the second numbers. So because you have to use distributive rule. Oh, one of the advantages I can show you using the head is following, because you can do this calculation like a 3 1 head. So if you need so-called the vertical form, 3 1 head, right? I got the 3 1. I can do the calculation pretty easily. That is 1 times head, that is negative number. 1 times 3 is 3. 3 times 1 head actually is negative number. We got the 3 head. 3 times 3 is 9. You add them together, you got the 1 head. And the 3 plus 3 head is 0, you got the 9. Lots of cancellation. So therefore, this number equal to 901 head, which essentially is 899. And later on, a student can do that mentally. In particular, this is related to so-called the polynomial multiplication. 3x minus 1 times 3x plus 1 because they are essentially the same. From here, you got 9x squared minus 1. So they are the same things. Okay, I stop here.